Imagine you're deploying your code to AWS or some other cloud environment, and you're prompted with some networking related settings and options that you don't really understand what they're asking and what choices you should make. If this sounds familiar, you're in the right place. Networking for developers is not intended to make you a network engineer, but to help you understand the basics just enough so you can make good choices for your application. Let's get into it. So consider the simple network diagram that we've got here. 4 computers connected together in a wired network. When one computer wants to send information to another one, it's going to send a packet. A good mental model to think of is a postcard, because a postcard's got a to and a from address, and it's also got the message, the body of it is visible. That's a better analogy than a letter where the contents of the message are only available to the recipient that opens the letter. So anyway, imagine that in this case, computer 1 is going to send a packet to computer 3. Computer 1 is going to write that packet. Imagine it going around in the circle. Each computer looks at the to of that packet and says, that's not for me, that's not for me, oh, that's for me. So computer 3 is going to read it off of the wire and then go look at the body. This design of every computer reading the header, the address information of each packet, works when you've got a small number of computers, but it doesn't scale well. If you grow to hundreds, thousands, or even millions of computers, like on the internet, this model does not scale. So we've got to come up with a different way of computers communicating with each other. And so what we end up with is, instead of one giant network, we have a network of networks. And that's really what the internet is. It's a network of networks. So now consider this new diagram. Instead of adding additional computers to one network, we've split it into 2 networks, and it's connected with this thing called a router. Notice that the router to network A looks just like another computer that we're going to call A4, and to network B, the router looks just like a computer, and from network B's point of view, its address is B4. So if A1 sends a packet to A3, it's going to work just like before. It's going to go on the wire. A2 will ignore it. A3 will read it because it's addressed because that's who it's addressed to. The router is also going to ignore it. On the other hand, if a packet is sent across the network from A1 to B1, A1's going to put it on the wire. A2 and A3 are going to ignore it because it's not addressed to him, but the router, doing special duty here, says, I'm the one who is going to get that packet from network A to network B. It's going to read it from here, it's going to write it to there, and then the same thing that happens on the previous message, B1, B2, and B3 are all going to consider it. B2 and B3 are going to ignore it. B1 is going to read it because that's who it's addressed to. The router only moves traffic from network A when it's addressed to network B. There's a little bit of an assumption here that these computers on network A are going to communicate with each other more than they're going to communicate with network B. So the router is acting as kind of a traffic cop. The only traffic that crosses the connection between network A and network B is stuff that's needs, the router is smart and only puts the things on the network B wire that need to go across. This routing functionality is really what enables the internet to exist, because routers keep the majority of the local packets local, and if everything went on every wire, it just wouldn't scale. So network routing is the magic that basically has allowed the internet to become what it is now. So you can see here at this point, imagine that network B has evolved in complexity and got added more and more computers, more and more networks on that side. From network A's point of view, there's no difference. Network A works just like it did before, and what's on the other side of the router is kind of a black box to network A. It just knows what's happening on its side of it. An analogy may help here. At the end of the year, we send Christmas cards to friends and family. We tend to hand deliver the cards to the people in our neighborhood and let the post office handle the rest. You could think of us as being computer A1 here and our neighbors as being A2 and A3. But for everybody that's not in our neighborhood or not in our local area network, we're going to enlist the post office to help for that. Similarly, A1 is going to enlist the router to get it the rest of the way across the internet, just like the post office does. I don't know the inner workings of the post office. I don't need to know, if I'm computer A1, the inner workings of the router. I just need to know this is not in my neighborhood, or this is not in my local network. So I need to send this to the agency, the post office, the router, that's going to deliver it the rest of the way there. So now I've got a concept of near and far, or local and remote, and just like I'm going to decide I'm going to hand deliver this one or I'm going to let the post office handle it, the computer looks at local and remote to decide, is this going to be a direct delivery, or do I need to hand this packet to the router and let them take it the rest of the way? So now we need to drill down on how the computer makes the local versus remote, near versus far decision. The answer is the subnet mask. Because I want to keep these videos short, we'll get into that on the next one. Networking for Developers is brought to you by Circlebox and CBITS. I'm Jeff Trotman. Thank you for watching.